So today, we are not that far yet, brother.
I didn't see it on the back side.
So that's actually the front side. You were on the back side. So today we're typically front side is indicated by having hole punches on the left. Today we're going to be doing two things. We are going to be quiet. So we're doing three things. First is you're going to be quiet. Second, what we're doing is we're going to be reviewing exactly what we did last Tuesday. And also we're going to be reviewing what we did when we first learned about decimals. So yesterday we just did decimals. Today we're combining decimals and also solving equations using addition and subtraction. So the addition property of equality, you guys defined that last week. And it said if you add the same number, including decimals, to each side of an equation, the two sides remain equal. To visualize that for you, just imagine that I have a scale in front of you. And on each side of the scale, I have 5 pounds. If I were to add 7 more pounds to each side of the scale, yeah, isn't it going to stay equal?
Yeah.
Okay, because it's not going to wobble one way or another. Okay, that's the same situation. The addition property of equality, if you do both to both sides of the equation, it stays equal. Then the subtraction property of equality is the exact same, where you subtract the same number, including decimals, to each side of the equation. The two sides remain equal. If you have 5 pounds of dirt on either side of a scale, you remove 2 pounds of dirt from each side. The scale is still going to be level. Any questions on that? Okay. Does that make some sense? Okay. Yeah, it does smell really good. In-class examples. Now, some of you, this is going to be super duper easy. Actually, a lot of you, this is going to be super duper easy. However, we are going to be still doing this. Huh. I'm going to leave that open. We got a nice until the breeze comes through. It's really easy for a lot of you, but that's okay. It should be really easy for a lot of you, but I do want to make sure that you are taking your time with this and we are getting these correct so you don't make any silly mistakes. We will be getting the quiz back today, and you'll be able to see and ask questions about what you did wrong. So I'm going to use blue. So since we have, how big is this? Since we have y plus 7.2 equals 21.9, what's the first thing that we have to recognize about this? Well, actually, it was actually the first question on the quiz. Are you taking the quiz, by the way, right now? You ready for it? Yeah? Okay, I'm going to give you a quiz before I tell you the first answer. Okay. So what's the first thing we need to know about an equation like this? Okay, 7.2 is being added to it. And why is that significant? Because what's our goal whenever we see an equation? What's our goal when we see an equation? Only one person out of all of you knows the response to this. Thank you, Will.
Find out what the variable is.
And how do we do that?
So we undo if what's being done to the final answer.
You have to undo what's being done to the variable to get the variable by itself. And when you have the variable by itself, you have defined the variable as what's missing. Okay? And because this is addition, what do we have to do to undo it? You already said that, didn't you? Okay, what is it?
Subtraction.
Subtract. Because it's addition, you have to subtract. And for Sammy's review, if it were multiplication, what we have to do? Divide. Yeah, that's tomorrow. The numbers are kind of messed up on this. So I want you to do, can you guys do number 1 right now while I'm getting Sammy set up? Pretty exciting. Can you not bring your math folder out or binder out there when you do a math quiz? I know you weren't doing it on purpose. You can use this, though, if you want something hard to write on. Okay, Will, what did I do here? What did you do here?
I subtracted 7.2 from 21.9 and did the same for 7.2.
Good. Minus 7.2. And because it is a positive that's bigger than the one that's being subtracted, what is my What is my difference going to be, Tyler?
14.7.
14.7 is correct. 14.7. 14.7. Good. Now for number 2, I'm going to walk you through this one. For number 2, what's happening to the variable is 5 is being taken away from it. So to make it back to just being the variable, I'm going to have to add 5 to either side. Now here's the trouble with this. Okay, I'm lining up the decimals. We are going to have a positive or a negative sum there. It's going to be negative because our integer, or our number here of negative 13.7 is bigger than what's being added to it. So if I'm looking at a number line, and I'll do this visually, I did it standing in front of the group yesterday or earlier. So here's a 0, negative 5, negative 10, negative 15. So if I am at this point, negative 13.7, that's about here. If I'm at this point here and I'm adding 5, I'm going to be finishing about right there, right? Yeah. Is that negative or positive still?
Negative.
Negative. So here's an integer review. AJ? Negative 8.7. Sure about that?
Yeah.
Okay. How do you know?
Well, because with the, you add 5 on each side, but with the 13.7, since you're adding with positive goes that way when you're adding.
Good. Yes, because positive is going this direction. And here's a way that you can do this. If I change all of these signs, so that's a positive, that's a negative, it makes the negative here. All you need to do is do 13.7 minus 5. 7 minus 0 is 0, or 7. 13 minus 5 is 8.7, which is B. That's a really great way to do it if you flip all the signs because you're going to be getting closer to 0. The biggest thing you can't forget is to put this negative in here. Okay? Put that negative in there. One more to walk through. Any questions? Oh, yeah, any questions on that? So it's integers, familiarity. Now we have m minus 4.1. What is happening to it, Ellie? What's happening to the variable in number 3? Yep, so how are we going to undo that? So she said it's subtracting 4.1 from it. Nope. We're trying to undo stuff to this guy. So what do we talk about this first? We're not worried about that guy yet. How do we undo what you just said, which is 4.1 is being subtracted from it? There was the biggest concept of last week. The first thing we learned about. What is the opposite of this? Adding. So what are we going to add to undo subtracting 4.1? We have to do the opposite of this to get m by itself. So what's the opposite of negative 4.1? Positive, also known as adding. Yes, see, you got it. So this comes m over here. Add 4.1 to this guy. And I'm going to change all the signs on this because this would be adding, but I'm going to take that, have a negative. So we have there, and there, negative 5.28. Yes, sir?
I did like you did 1, and I still got the same thing.
Like you did 1?
I did 9.38 subtracted, minus 4.10, I still got 5.10.
If you subtracted, so please stop making that noise with your mouth. If you subtracted 4.1 from negative 9.38, you would have negative 13.48. I'll come check that out while you guys are doing number 1, 2, and 3 if you think about it. Okay? I want you to answer those 3 right now. I'm going to give you 5 minutes to answer those 3, and we'll discuss what would be a good, better, and best answer. So, YouTube, bounce ahead 5 minutes. Okay, I just had the question is why would we switch the signs? New page. It's only 50%. I'm going to delete that. There we go. So what are the numbers? 13.7. Okay. So we were at negative 13.7, and it was negative 13.7, and then it's minus 5. 13.7 plus 5. So when we're doing negative 13.7 plus 5, so we're at negative 13.7, which is going to be 1, 2, 3. We're starting there. When we add 5, we're going to be going 1, 2, 3, 4, 5 to that spot. So we're still in the negative. So when we're going positive, when we're adding 5, as far as the signs go, is it going to be a negative integer plus 5? You're getting bigger, right? But if it was an absolute value, would that absolute value get smaller or bigger? Bigger, it gets smaller because you're getting closer to 0. So we had the negative 8.7 where it ends up, but visually I really can't think of that. Or some might be able to make sense of that, but when you line it up this way, 13.7 plus 5.0, you see this plus sign and you're automatically going to think, or some might automatically think 18.7, when it's actually mimicking, ooh. it's actually going to mimic something more like this, where it'd be 8.7, right? And we switch all the signs, and it's back to where it was. Okay. It's just, if you visualize this here, you'll know if it makes sense that you got closer to 0 or that, or whether it should be positive. In the integer rules that we did Monday, that'll really help you out. Yep. Okay, it's been 5 minutes. So what property would you use to solve this equation, Anthony?
Addition property of equality.
The addition property of equality is correct. The addition property of equality. If you just said addition, no, it's not the addition property. It's the addition property of equality. Okay? Equality. Now, explain how to solve. So if you just have that written out solved, no. I want to hear an explanation. Yes?
To get n by itself, you have to reverse it on both sides. So you have to add 8.9 to both sides of the equal sign to get n equals 15.7.
Okay, so we added 8.9 to both sides. Good job. Yes, that is correct. So you added both sides. So what she said was, we need to get n by itself, and we need to, in order to do that, we have to undo what's being done to the variable, which is being subtracted by 8.9. So we have to add 8.9 to both sides because of the additive property of addition. Good. Now, how about, there's a couple different ways of saying number 3. Tell how you know that 6.9 is not a solution of n plus 8.5 minus, or equals 14.7. What do you have for that, Beeler?
I can tell it's not because it says n equals 6.9. When I added 6.9 by 8.5, it equaled 15.4.
Good.
It's not 14.7.
Okay, so that's one option. You plugged in the variable, and if it doesn't equal 14.7, it's wrong. Good. Will.
Because after subtracting 8.5 from 14.7, which is needed for this problem, I got 6.2, which is not 6.9.
Good. So 6.2 is not equal to 6.9. Even if you had no idea what was going on in this class, would you be able to go to any child, adult, that knows, wait, what was the two numbers?
6.2 and 6.9.
Would you go to any child and be like, is this true? No, because 6.2 is not equal to 6.9. They're different numbers, right? So that's how you check to see if you found the correct solution. There was a couple of you, I think, that did that on the quiz. You were checking your work, which is good if you have time, and I know that you had time because I don't think there was any of you that took the whole class period to take the quiz. But that's as simple as that. When you check it, if it doesn't equal the correct one, which would be 14.7 or however you work it out on both sides, you would be, yeah, you would know that you did something wrong. Okay? You drop it back. Here. So, here's what you're going to do. You are all going to start working on these here. You don't have to do number 7, 11, or 13. I'm going to be passing out your quizzes. Then in, 7 minutes or so for my local students, I'll put the answers up there. For YouTube, I'll put the answers up there right now. But you're working on those. I'm going to pass out your quizzes. You don't have to do number 7, 11, or 13. Then if you have questions about the test or how I found the solutions to these, you will have that time to ask questions and I can answer them. So that's it. And yes, 7 minutes for my local students.
Is this for homework?
No, this is not homework. This is to check and see if you have any questions, especially when the solutions are up on the board. Okay, let me just pause the stuff here and get YouTube ready. Bye, YouTube.